One use of trig identities is for the purpose of simplifying trig expressions. So if we look at this first example, simplify the following expression using established identities. So what we want to do is we want to simplify this fraction, 1 minus cosine squared theta over sine theta. So this example, it's already worked out. Okay, and there's always already a solution, but I'm just going to kind of talk you through it. And then you can use the insight, from this example and try the think, pair, share next on your own. All right, so this is what we have to start from. And so what you're looking for other equations, other trig equations that you can use to maybe transform or manipulate, this expression. And sometimes when you transform a part of it, it allows you to perform, other algebraic operations that you already know. And those algebraic operations thereby let you cancel things out, simplify the numerator, denominator, or both, and come to a much simpler expression than what you started with. All right, so we're looking at this one, and the first thing I'm going to look at is the numerator, 1 minus cosine squared theta, and I kind of don't know what to do with it initially, actually. So what I'll do next is I'll look at my list of trig identities. And, we got a whole page of them. All right. But looking at this page of trig identities, you want to look for an identity that maybe could provide some use. So, yeah, we've got a sine theta. We know that's y over r. Let's see. Here we've got cosine theta. That's x over r. We have these these reciprocal trig functions here. And we have these Pythagorean ones. Now, what makes these Pythagorean ones a little bit more interesting is you can see they've got the trig functions squared, and it has a 1 in it. So if we go back and we look at our expression, you can see we've got a 1 and a cosine squared. So maybe the Pythagorean identity is the one that we would use. All right, so let's come back here. And it's possible we could use this one. So the first thing I would do is I would just go ahead and rewrite this one next to your problem. So part of this is a trial and error process. So if we had cosine squared theta plus sine squared theta is equal to 1. Now, when you look at this original trig identity, what you have on the left does not appear to match anything that we have here in our expression that we're trying to simplify. Okay, but this is where, the algebra of manipulating equations comes in. Because now if you subtract cosine squared from both sides, okay, so you've got a positive cosine squared here and a minus cosine squared there. These two will add up to 0. And now we've moved this cosine squared to the other side. Well, look at what we have. Now we have this expression, which is actually our numerator. So it means anywhere we find this in our expression, we can exchange it with that, sine squared theta. So if we take this numerator of 1 minus cosine squared theta and we replace it with sine squared theta, then this is what we get. And maybe as an intermediate step between this one and the answer, this is sine theta times sine theta all over sine theta. So you can see sine squared theta is just sine theta times sine theta. And this sine theta in the denominator cancels out with a single sine theta in the numerator, leaving a sine theta left over in the numerator. Okay, and that's where that answer comes from. So, let's erase all that. So this expression right here simplifies down to that. And the way we were able to simplify this expression was to apply the Pythagorean identity and kind of mutate it a little bit so that it would fit our needs in this simplification. Okay, so using this example as a model, try the think, pair, share on your own. Okay, we're back. So this one is very similar to the last one. We are going to be using the Pythagorean identity. So that's cosine squared theta plus sine squared theta is equal to 1. But instead of subtracting cosine from both sides, we're going to subtract sine squared theta from both sides. And then this will add up to 0. So a different form of the Pythagorean identity is going to be this identity. Cosine squared is equal to 1 minus sine squared. So you can see here, this 1 minus sine squared, we can replace that with cosine squared in the numerator, and denominator stays the same. And as I mentioned, cosine squared theta is cosine theta times cosine theta, and that's all over cosine theta. And we can cancel out one cosine theta in the numerator with 1 cosine theta in the denominator, leaving us with just cosine theta. So this expression, 1 minus sine squared theta over cosine theta, simplifies down to just cosine theta. All right, let me know if you have any questions.